Chapter 27, page 784, number 56. Make sure you've read the question before you go any further. We're told that in the Sun an ionized helium atom makes a transition from n equals 6 to n equals 2, emitting a photon. And we're asked, can that photon be absorbed by a hydrogen atom present in the Sun? And if so, between what energy states will the hydrogen atom jump? So what we're looking at here is that helium relaxes from a highly excited energy state, n equals 6, down to the n equals 2 state, and emits a photon which will have a certain energy, and we want to know, can that photon be absorbed by the hydrogen atom? So the plan of action here is find the energy of the emitted photon and then compare to hydrogen energy levels. Now, a helium atom has more protons in its nucleus, twice as many as the hydrogen atom, and so it's going to bind those electrons more tightly. They're more strongly attracted to it. So the energy levels in helium are not the same as in hydrogen. It takes more energy to take an electron off of helium than hydrogen. And the reason they make it an He plus ion is that that's only going to have one electron. So the helium is going to look like this. We've got 2 plus charges in its nucleus, and because it's an ion, we've just got one electron going around it. Meanwhile, hydrogen atoms have 1 plus charge in the middle and 1 electron going around. So this is what the two things we're considering look like. This one is going to emit a photon when it relaxes, and this one we have to find out whether or not it can absorb it. Now, it turns out, as you might have seen in the reading, that the energy levels depend, in fact, not on Z, the charge of the nucleus, but on Z squared. So 1 over lambda, which is for hydrogen, 1 over lambda is R 1 over n squared minus 1 over n prime squared. But for helium, it's Z squared, 2 squared, it's 4R 1 over n squared minus 1 over n prime squared. And for the transition we're given, which is 6 to 2, it's 4R times 1 over 2 squared minus 1 over 6 squared, which simplifies because it's R times, that cancels, so we end up with 1 over 1 minus, and then 6 squared is 36. 4 over 36 is 9, so minus 1 over 9. And when we look at that now, that kind of conveniently looks like 1R times 1 over 1 squared minus 1 over 3 squared. So the transition from 6 to 2 in helium has exactly the same wavelength and energy in transition as the transition from 1 to 3 in hydrogen. So the original question is, can it be absorbed by hydrogen? And if so, between what energy states will the hydrogen atom jump? Well, it can be, and the hydrogen atom will jump from the n equals 1 ground state up to the n equals 3 excited state.